Welcome back. We're using the percent of change equation to solve real-world situations. So let's look at a few more. Let's say last year a U.S. city had 8,052 robberies reported. 8,052 robberies. That's quite a bit. This year the same city saw an 11.4% drop in the robberies reported. How many robberies were reported this year? Okay, so we want to know the number reported this year. Okay, this is a percent of change equation problem. So let's identify some parts. Here we have a percent sign, so we know that that's actually a percent of change. Now remember, we're dropping, 11.4% drop in robberies reported, so this is going to give us a minus 11.4%. And when we're converting it to a decimal, we have a minus 0.114. Okay, always remember to tack on our minus sign because that'll affect our answer. When we're decreasing a certain percent, it's a minus percent. It's a negative percent. Okay, and what's on the other side? Our percent of change equals our actual change divided by our original amount. Okay, well, we don't know the final amount. That's actually what we want to solve for, the number of robberies reported this year. We do know the original amount, though. Last year, 8,052 robberies were reported. So we want to know the actual change. So we're going to let x equal actual change. That's what we need to solve for in order to find out the number of robberies this year. So it's x up here, and we can simply solve for x here. We have x over 8,052. What we're going to do is multiply both sides by 8,052, trying to isolate our variable here. We have minus 0.114 on the other side. We're going to do the same thing on the other side, 8,052. These two terms cancel, leaving x by itself on the left side. And we have a minus 0.114 times 8,052. And this is going to give us a minus 917.928. Okay. Since this is a decrease, let's subtract this number from last year's number, the original amount, to get this year's number of robberies reported. Remember, we need to know what we're actually being asked to solve for here, and it's actually this, the number of robberies this year. This is the actual change in robberies, so we have 8,052 minus 917.928. Now you wonder why we don't just do our rounding here and subtract a whole number from a whole number. That's actually kind of important, so we're going to leave off our rounding till the end, and I'll tell you why in a second. We're going to subtract 8,052 minus 917.928, which gives us 7,134.072. Okay? Now, since we're talking about a quantity of occurrences, such as robberies, it doesn't make sense to have a partial robbery. So we can actually omit the decimal and everything after it, and or basically round down if you want to look at it like that. Okay, and actually the number of robberies reported this year will be 7,134. Okay, because we can't have a partial robbery. Now, furthermore, saving all rounding until the final answer, what it does is ensures us that we're rendering an accurate answer. Notice if we rounded up here, if we rounded minus 917.928, and before actually subtracting, we would have subtracted a 918, which would give us a different answer. So we want to keep all our rounding to the end, to ensure us that we get an accurate answer. We don't want to round on the way. We want to simplify always on the way, but we want to save our rounding to the end. We'll do some more examples, and hopefully we'll get a better understanding of that. Let's see. Let's say we have a piece of property that was valued at $115,000. It was valued in 2004. The same property was appraised at $176,000 in 2014. Okay? What was the average annual percent of change of the value of this property. We're wanting to find out the average percent of change per each year for each year. The average percent of change. Don't get excited here. What we're simply looking for is the percent of change averaged out over 10 years, 2004 to 2014. So let's take one step at a time, and let's start by finding the percent of change. So we have, we want to find the average percent of change here, so we're going to let x equal the percent of change. Okay, we don't see a percent anywhere in our problem here, so in the information we're given, so actually a percent is what we're going to want to find. So x equals, in our percent of change equation, the actual change over the original amount. So the actual change is going to be the final amount, 176,000, minus the original amount, 115,000. That's going to give our actual change, divided by the original amount, which was 115,000. Okay, one step at a time. 176,000 minus 115,000 is 61,000. 61,000, and then we still have 115,000 on the bottom, which is our original amount. We can cancel these zeros. We have a bunch of zeros on the end, so they can cancel, 3 of them and 3 of them. It's left with 61 over 115, which is the same as a positive percent of change of 53.04%. This is the percent of change. Now, we want, this is the total percent of change. Now, to get the average percent of change from 2004 to 2014, we simply divide by the number of years, which is 10. So we just simply divide 53.04% divided by 10 years. We want to average it out over the amount of time. Remember, this is a plus, which will give us a plus 5.304%. And that's per year. So the average annual change for that piece of property is a positive 5.304% per year. Okay, so let's make sure we just take it one step at a time and make sure that we're actually answering the question being asked, which is this: the average percent of change for each year. I want to know each year. So let's go ahead and squeeze in one more. Let's get some space, and let's do one more. Let's say we have 2 stores. We have store A and we have store B. Okay, we have 2 stores here. They both sell computers, and store A is selling a particular computer at a 20% discount. 20% discount. That's off of its regular price of $300. Regular computer price of $300 is being sold at 20% discount at store A. Store B is selling the same computer at an everyday price of $320. Okay, and it's also having a store-wide sale of 25%. So everything in the store is on sale for 25%. We want to know which store offers the better value for that computer. Now, this is actually a really good exercise for the prudent shopper. We'll need to set up 2 separate percent of change equations, one for each store, and compare the prices after their respective discounts. Okay, so we're wanting to buy a computer. We want to know which one's the better deal. So let's go ahead and take one step at a time, one store at a time. Let's start with store A. Let's set up a percent of change equation for store A. We know the percent of change is 20%, and it's a discount. So we're going to have a minus 20%. The price is going down 20%. So our percent of change is minus 0.2. Okay, and on the other side, we have our actual change divided by our original amount. We don't know the actual change, but we do know the original amount of $300. That's its regular price. So we're going to let X equal actual change. That's what we need to find before we can actually find its final price. And we're going to solve for X. So x over 300 equals minus 0.2, minus 0.2, and we're going to solve for x. So let's multiply both sides by 300. These two 300s cancel, leaving just x on the left side, and minus 0.2 times 300 is a minus 60. Okay, so the actual change in price for store A, it went down $60. So to find the final price, we subtract that 60 from the original price. If it went down $60, we take $60 off the original price, and that gives us $240. So this particular computer sells at store A. It's on sale for $240. All right. Now we want to compare it with the final price of store B after the discount. So let's go ahead and set up the equation for store B. Okay, there's nothing fancy here. We're just taking one step at a time, using a percent of change equation for both stores. All right, so again, we know a percent of change here. Percent of change is negative because we're having a 25% sale. So the price is going down 25%. So our percent of change is minus 0.25. Okay, now we need to find the actual change in the original amount. Again, we don't know the actual change, but we do know the original amount. It has an everyday price of $320. So we're going to let x equal the actual change. Actual change. And that's what we're going to be solving for, is x. So we have x, putting our variable on the left, which is, I usually feel more comfortable with having our variable on the left, and minus 0.25 on the right, minus 0.25, and we're going to solve for x. We're going to multiply both sides by 320. 320. These two terms cancel. This is going to be left with x on the left side. We're going to have a minus 0.25 times 320, which is going to give us a minus 80. So the sales price is $320 minus $80. So we subtract $80 from our original price, and this gives us $240. Okay, so the discount price for the computer for store B is $240. So the actual, when we compare the two prices, the discount prices for both stores are the same. Both are $240 for the same computer. So actually it doesn't matter what store you prefer to buy from, the price is going to be the same. So it's kind of cool how this worked out. But this is the basic theory here is we're setting up a percent of change equation for both stores. They're going to be independent of each other, and then we finally compare the sales price at the end. So working with percent of change equations, go back and review the applications that we looked at. This is actually very useful in everyday life. So be sure you get a good handle on it, and I'll see you soon.